Hi, welcome to Statics and Dynamics. Today we are going to look at a new problem which involves converting symbols to pictures. So, it is a portion of a gusset plate, and this thing is called a gusset plate. And these things are rivets. You will learn some of the technical stuff now. So, I'm going to tell you a little bit. So, those are called rivets. We know the magnitude and direction of this force. That's completely known. We have no idea about this force. But what we know is that the resultant force is 5,000 newtons in the negative x direction. So the resultant force is like that. So this is the x direction, that's the y direction, and the resultant force has to be like that. Okay, so that's the problem. I'll give you 1 minute to kind of look at this problem and really read it carefully. Okay, very good. So now, before we solve it, I want you to understand that the idea is to convert this picture into symbols and then do the calculation. So here is my symbolic world. Do the calculation and then switch back. Okay? So if you want to do that, we first have to be able to translate some things. So first thing I know is force F1 has magnitude 2 kilonewtons. And we know its direction 30 degrees. We are asked what is F2 and the question of what is meant by resultant force. Resultant force means vector sum of the two forces. I have to do vector addition of the two forces. Is 5,000 newtons, so we know its magnitude 5,000 newtons in the negative x direction. So its negative is minus, its direction is minus x. So it's that way. So I want you to understand that means that the x component of the resultant is minus 5,000, y component is 0. Okay. So this is the problem. This is a fairly simple one, and you might be wondering, what the heck, who cares about gusset plates, where I've never seen a gusset plate, etc. Yeah, you probably may not have seen, but it is essential to our everyday life. So we just don't know about it, that's all. So I'm going to teach you a little bit about what is a gusset plate. So we are now going to talk about the real world here, right? So what the heck is a gusset plate? For this, you should know something about how important gusset plates are and where do they play a role. So this particular bridge is the I-35 West bridge in Minneapolis in the United States, and this is a fairly chilling video of the bridge actually collapsing. This is not a animation, this is not a reenactment, this is actual collapse of the bridge. It was caught by a camera which was sitting up there. Okay. So, you will see what happens. So, there's the bridge, everything is fine, and then abruptly and suddenly you can see the cars on top of the bridge. Abruptly and suddenly the whole bridge collapsed. 13 people were killed. This was during peak hour, lots of cars were damaged and so on, and all of it had to do with a gusset plate. It's here. Can you see this gusset plate here? Oops. So this gusset plate is actually what holds the pieces of the bridge together. It's a reinforcement plate on the side of the bridge. What happened was, it was under-designed. What I mean by under-designed was, it was thinner than it was supposed to be in the first place. What happens when you do that is that, if you make it very, very thin, then the bridge will collapse when you build it. But if you don't do that, it's like a sitting time bomb. What happened was, they built an extra layer on the road, which added additional load on this. And on that particular day, there was 300 tons of stuff sitting directly over this gusset plate, right here, 300 tons. Okay, that's what caused the collapse. That's how it works. Okay. So the reason why we look at gusset plates and all these things which you don't regularly see on everyday life is that these are essential for the kinds of things that we take for granted. Bridges are the things that we see, but the underlying things behind the bridge is the gusset plate, and those are the things that we don't see. Okay, so now our translated version, this is our symbolic version. Given F1 plus F2, find F2. That's an easy problem, right? Vector, once I write it in the translated version, then the problem becomes fairly straightforward. So I have to decide whether I'm going to do this by trig or vectors. Answer is going to be vectors. You can also do it by trig, but we're going to do it by vectors because neither magnitude of force nor direction is known for F2. So when that happens, many times it's better to do by using vectors. By the way, this is a guideline, and if you know, I mean, I am from India, and in many parts of the world, guidelines are different from rules, right? So in many parts of the world, guidelines are things that sometimes you have to violate. Most of the time, you're kind of following them, that kind of thing, like traffic guidelines, right? So in India and other places, there are no traffic rules. There are only traffic suggestions. You know what I mean, right? Like that, guidelines are initial things to try if you don't know anything else. It may not always work, but they are very, very useful things to keep. So these are called heuristics. And having a list of heuristics is important if you want to solve problems efficiently. There are other ways to do it, and sometimes your heuristic may not work, but it's a good starting point. Okay, very good. So now we know what to do. So first thing, I want to find F2 equals vector equals minus 5000 comma 0. This is the resultant minus F1. Now comes the question, what is F1? We know that it has to be 2 kilonewton or 2000 cos theta comma 2000 sin theta. Right? We know that. But the problem is, this is not theta. And you're wondering, hey, why not? That's the angle it makes with the x-axis. Be very careful. Please remember that the correct way to do that is go to the base and draw coordinates x and y. I told you this, no? Start from the base of the vector. That's why I tell you about Royal Road. If you do a shortcut, you may be in trouble. So the reason is F2 is actually pointing this way. You see what I mean? It's pointing into the third quadrant, not into the first quadrant. So be careful about this. If you put it at the base, there is no problem. And our Royal Root suggests that this is the angle that I want, theta. So how much is that? Can you see it will be 300 degrees? So I want you to understand why is it 300 degrees? If this is 30 degrees, this angle is 60 degrees, right? So it is not even 300. It is theta is 270 minus 60 degrees, which is 210 degrees, right? So now we are ready to compute. So this is the point, that's why I'm writing it in red. 2000 cos 210 degrees, 2000 sin 210 degrees, which turns out to be, I'm going to do the calculation right here, 2000 times 210 cos equals minus 1732 2000 times 210 sin equals 1000. Sorry, let me do this right. 2, 1, 2, 3. So it's minus 1000 newtons. Right? So now I can do F2 equals minus 5000 comma 0 minus 1732 comma minus 1000, which turns out to be minus 3628 comma 1000. So we now know the x and y components of F2. Now we can convert it back. So please remember, make sure you get the notation right. F2 is a vector. So now I'm going to write F2 scalar equals square root of 3628 squared plus 1000 squared, which turns out to be, sorry, 3268. I should have been careful. Let me get the numbers right. So it is minus 3268 comma 1000. F2 is 3268 squared plus 1000 squared, which is 3417.6 newtons. How about the angle? This angle. So phi, which is, so first thing I do is I look at Fy, sine is positive, cos inverse, Fx, which is minus 3268 divided by 3417.6, which turns out to be equal to minus 16.3 degrees. Okay, so that's our answer. Okay, that's how it works. Thank you.